Okay, in this presentation we are going to look at a normal distribution question. So this is related to car tyres and how long car tyres last. A tyre manufacturer claims that under normal driving conditions, the tread life of a certain tyre follows a normal distribution with mean 50,000 miles and standard deviation 5,000 miles. So there's two questions here. If your tyres wear out at 45,000 miles, do you consider this unusual? Support your answer with the appropriate probability calculation using the normal curve, the normal probability distribution. And second question is, if the manufacturer sells 100,000 of these tyres and warrants them to last at least 40,000 miles, okay, so he's sort of guaranteeing more or less that they should last to 40,000 miles, how many of these tyres will wear out before the warranty expires? So those two questions there. So we're just given some parameters for this normal distribution. We have a mean mu of 50,000 miles and a standard deviation of 5,000 miles. Okay, I'm just going to work in thousands of miles, but you can sort of like denominate it, or sorry, just miles as is, but you can't denominate it in terms of thousands of miles, which would make sense. Okay, but I'm just going to sort of stick with what is given. Okay, so exercise 1 is 45,000 miles unusual. So that's a sort of bit of a subjective thing to say, but we'll just sort of like look at the numbers anyway. To determine if 45,000 miles is unusual, you need to calculate the Z-score and then calculate the corresponding probability. So Z-score is as follows. That is the normalized value, the Z-score. That is the raw value minus the mean divided by the standard deviation. Okay, so here our value that we're interested in is 45,000 miles. The mean is 50,000 miles and the standard deviation is 5,000 miles. Now this is obviously deliberately picked to be a sort of straightforward enough calculation. Okay, so that is 45,000 minus 50,000 divided by 5,000, which is minus 5,000 divided by 5,000, which is just minus 1. So we have a Z-score of minus 1. Okay, now this is where we have to use the probability tables. Usually at this level you might be using with a probability table such as the Murdoch-Barnes tables, and what you're trying to do here is calculate the Z-score that corresponds to Z minus 1, Z equals minus 1. Okay, now there's a couple of things you have to do here, but essentially the probability of Z being less than minus 1 can be found using the complement rule. And using the complement rule, the probability of Z minus 1 is equal to the probability of Z greater than or equal to 1. Okay? And if you're looking up at tables, it should be 1.00. Okay? So the row 1.0 and the column 0.00. If you're not familiar with the tables, I think we should probably spend a bit of time working on where to get Z-scores rather than trying to jump into questions like this. But you should get an answer of 0.1587. So the probability that a tyre wears out at or before 45,000 miles is approximately 15.87%, which is not, it's a sort of not really unusual. It's below average, but it's not massively unusual. Okay, now what I'm going to do here is just actually show you the bell curve here that would correspond to this question. Okay, so here we have the bell curve, the normal distribution curve that is denominated for car tyre lifetimes. You see the peak there is at 50,000. It's probably not great, but you can trust me there. 50,000. The shaded area, the pink shaded area there, corresponds to the area that is less than 45,000 miles. And while small, it's not conspicuously small. It still occupies a fairly large chunk of the bell curve. So we're going to say it's not particularly unusual, but it's noteworthy, but not particularly unusual. Okay, so next one is the tyres wearing out before 45,000 miles. To find out how many tyres will wear out before 40,000 miles, we calculate the Z-score for 40,000 miles and then find the corresponding probability. Same as before. Okay, Here, what we're going to do here is, again, just look at the bell curve again. The shaded area there, the pink shaded area on the bottom left, is this area that corresponds to the probability of less than 40,000. Now you notice it's actually much smaller now than the previous question. Okay, so the z-score is the raw value minus the mean divided by the standard deviation. I should call it the raw value, but it's what the value we're interested in. So that is 40,000. Okay, the mean is 50,000. The standard deviation is 5,000. So we have 40,000 minus 50,000 divided by 5,000. That's minus 10,000 divided by 5,000. That's minus 2. So we're interested in the probability of a z-score being less than or equal to minus 2. And using the complement rule, that is equal to the probability of a z-score being greater than 2. And if you're looking that up in the tables, you should get 0.0228. Okay. And so the probability that a tyre will wear out before 40,000 miles is approximately 2.28%. So if a manufacturer sells 100,000 of these tyres, the number of tyres expected to wear out before the warranty expires is 0.0228 times 100,000, which is 2,280. Okay, so about 2,280 tyres are expected to wear out before the warranty of 40,000 miles expires. Okay, that's good. We'll leave it there.